Hi everyone, welcome to Russell Lundberg's individual presentation in the 5G Theatre. Russell is the CTO at Bangkok Beach Telecom and will be speaking to us on the topic of OpenRAN developments. Any questions from the audience, please post them in the Q&A icon on your screen. And without further ado, I will pass you over to Russell, who will begin his presentation.
Hi, I'm Russell Lundberg, and in the next 20 minutes, you'll learn what is OpenRAN, and what will be the impacts that OpenRAN has on the mobile network, and how best to prepare yourself when that happens. So start by talking about what is OpenRAN. First off, OpenRAN has two primary objectives. First is disaggregation. Disaggregation means to separate the hardware from the software functionality, and also to carefully define the functional blocks of software and what are those interfaces. Specify those interfaces really clearly. The second objective of OpenRAN is vendor independence, and the point is to create a robust ecosystem of innovative providers. So here you see on the screen these two diagrams. All these separate little blocks are functionality within the mobile network, and the different colors are meant to convey the spirit of a bunch of different vendors running that functionality inside the network. I do have a PDF that you can download of many of the key organizations and institutions that are collaborating to define OpenRAN. You can get that at pages.cafetele.com/TWA. So this is kind of an abstract view of a typical mobile network today, where one color, it's one vendor. It's all a monolithic single vendor environment. Yes, there are other vendors. Maybe there's individual applications or services provided by third parties, but primarily all the mobile functionality, the core and the radio network are all a single vendor. Ericsson, Nokia, Huawei, these guys do it all for most operators these days. So how do we get from that monolithic proprietary architecture to OpenRAN? So straight away, here is a component architecture defined by the ORAN Alliance, one of those collaborators in the OpenRAN movement. And they have laid out these four components: the RIC, the Radio Intelligent Controller, the centralized unit, the distributed unit, and the radio unit. These four components work together to deliver all the radio network functionality. Here we've got kind of a simplified view of that ORAN architecture. Here's the RU, the DU, the CU, and the RIC. And the blue line in between the four boxes is the transport. And between the RU and the DU, that's the front haul. Between the DU and the CU is mid haul. And excuse me, between the CU and the RIC, or the core, is backhaul. So this is a very typical simplified diagram. I'm going to show it several more times throughout this presentation. So let's get to the actual impacts that OpenRAN is going to have. So the first impact derives from the separation of hardware from software. The point of that is that the operators should be able to buy the hardware themselves, source that in an open market for generic hardware, rather than paying the telecom vendor for a monolithic proprietary solution. So this will lower the CapEx cost by lowering the price of that hardware, and that hardware is often called COTS, commercial off-the-shelf hardware. And these are just white boxes that can be bought from just about anywhere, but they're very generic, no special requirements. Yeah. So COTS hardware should lower the CapEx requirement for building these network components. And I'm sure there are going to be operators who do just that. They will buy the OpenRAN software, they will buy the COTS hardware, and they're going to run this hardware on the they'll run this software functionality on the COTS hardware inside their own telco private cloud, a telco cloud. Equally certain though, there will be operators that don't even bother to buy the hardware. They'll get the software and they'll run it in a public cloud, on a generic Linux compute instance in a public cloud. And the reason that will happen is all the reasons that cloud computing has become so popular in the last 10 years, but architectural flexibility, diverse routing, dynamic resource management, scalability. These are all really important benefits that have tremendously changed the IT industry over the last 10 or 15 years and is now coming to telecoms. But paying for that software to run in a public cloud is a monthly recurring cost. So it raises the OpEx for the business. And that leads to the first impact of OpenRAN. Total cost of ownership will shift from CapEx to OpEx. And that's a very momentous change for the business that has many of other repercussions that I'm afraid we're not going to have time for in this short presentation. So continuing on to the next impact, OpenRAN with those distributed components that I've shown you, the RU, DU, CU, and the RIC, requires a very more transport infrastructure than we have today, than we typically use today. And that transport with the separation of front haul, mid haul, and back haul can be much more complicated. We have different topologies. So here's that simplified architecture diagram that I've already showed you with the transport connecting the 4 functional blocks. And here's what I'd call an as-built. This is one implementation of ORAN, those ORAN components. You have the RU and the DU running co-located actually at the site. And then there's a transport link to a cloud or mobile edge compute site where the CU and the RIC are running. This is one implementation. Just one more example. Here's a separate implementation with the RU and DU, again, running in the co-located at the site, with the CU running in a mobile edge compute site and the RIC running in a traditional data center. But now you have 2 transport links to connect them together. That's what I mean when you're going to have more transport topologies, and there's a lot of different variations in those topologies. Any operator that is today considering OpenRAN, because of the timing, will also be looking at 5G. If they don't want to do 5G now, they very quickly will. So whatever transport topology they're going to deploy now for OpenRAN will also support 5G in the future. And 5G has very considerable bit rate requirements. You really need fat pipes to connect those components. Some of those topologies that I've talked about have been specified by an industry body, 3GPP. And 3GPP also calls out the front haul, mid haul, and back haul. Some of these requirements, these bit rate requirements, are so significant that really the only way they can be serviced is using fiber optic cables. Let's take a look. So here's a 3GPP split options. This is on the front haul, and it defines the different arrangements of functionality between the RU and the DU. Now, although those functional blocks have been defined, 3GPP allows you, with these split options, to distribute some of the functionality between the RU and the DU. There's advantages to putting more of the functionality in the DU, but the disadvantage is it really drives up the bit rate requirements. You have to have much fatter pipes. So with this type of architecture, you can see for split 8 in this example, 236 gigabits per second. That's just not possible to do with copper or certainly a wireless technology. You'll have to have fiber. Even though there's some of these topologies that will be possible in the near term using copper or maybe a wireless link, over time, the bit rate requirements just keep incrementing up. So really, fiber is going to be essential. Here's another view. This one comes from Heavy Reading, where they actually call out the RU and the DU. That's that front haul link. And again, it's 100 plus gigabits per second. And then from between the DU and the CU, another 100 plus gigabits per second will be required. And then lastly, between the CU and the core, or I'll get to that, between the CU and the core here, the backhaul component, 400 gigabits per second. Tremendous requirements that can only be serviced using fiber optic links. I mentioned this arrangement here, the CU to the 5G core. There's another component of OpenRAN and 5G that's coming into play, and that's called CUPS, Control User Plane Separation. By control plane and user plane separation, that means the user data no longer has to transit the core. It always has in the past. Using CUPS, the user plane data, which is really the highest volume of the data at the CU, can be peeled out off to the internet using something here. I've described it as a DCSG, the Distributed Cell Site Gateway. All that user data can be peeled out at layer 3 and sent off to the internet, with only the control plane data actually routing through to the core. So in a sense, between the DCSG and the core, that will drop the bandwidth requirements. However, you'll still have that all that user data going off to the internet from the DCSG. All that transport, if not owned by the operator, must be leased, and that drives OpEx. And that will be the second one. Remember, we already shifted some of the compute into the cloud, which increases OpEx. Now, if we're going to be leasing a lot of our fiber transport, also driving OpEx, now we've got a problem. Although we've reduced our capital cost, we've dramatically increased our OpEx. So that's a problem. Because of that, the second impact is operators are going to scramble for access to more fiber. They're going to be, they'll want to build it themselves, or they'll want to buy a company that already has a big backbone, or they're going to be partnering up as a way to lower that OpEx and make the transport costs more affordable. Excuse me. So getting on to the next part of the OpenRAN objectives was the vendor independence. So here's that diagram again, showing all those block components, and with the different colors, different vendors are delivering each of those block functionalities. So you're going to have many more apps running inside the core of your network. Probably each app is going to be running on its own upgrade cycle. So you'll have lots of upgrades going on all the time. And there's no primary vendor like in the past to take responsibility for all that. So you've got this hugely diverse environment with lots and lots of changes. In addition to the actual network functionality, you've got a tool chain stack. And this is the software in which all that network functionality will be running. Certainly there'll be Linux. There's going to be your container or your hypervisor runtimes. There's the OpenStack and a Akrino. There's the Kubernetes, which is a container management. There's Docker, which is the actual container software. There's a tremendous number of these open source projects to actually run your cloud compute instances of all that software. Lastly, there's one more, and this is from the TM Forum Open Digital Architecture. The red part there is really the OSS BSS layer for your billing and your operating support systems and your orchestration software. All told, with all this software, you can see the operating environment is now going to be totally software-based, completely software-based. So that comes to the third impact of OpenRAN, that the operators have this a hugely complex software business that they're managed. Another huge change from the past where we had that vendor. The primary vendor took most of the responsibility. For us as operators, a lot of that vendor functionality was black box, and now it's our job to manage it. Big change. For the next impact, you have to ask, okay, who will take responsibility for all that software management? Well, we don't really know this yet because there aren't very many large deployments of OpenRAN at scale. The only example we have is Rakuten. Rakuten built a greenfield 4G network using OpenRAN principles in Japan, and they're really on the cutting edge. They decided to work with their vendors, but to manage it all themselves. They actually took responsibility, the systems integration role, for all the different software components. Now, again, in the past, that responsibility has often been delegated to the telecom vendor, the Ericssons, the Huaweis, the Nokias. We always called it having one throat to choke. It was a huge convenience, and really one of the benefits was it always gave the operator somebody to blame. Whether or not that was valid, it still happened. But the point to ask yourself is, why bother to go through all this disaggregation and to specify all those functional blocks and define those interfaces and then hand over the responsibility for managing it to just another third party, a systems integrator. It really makes the most sense to do it all in-house like Rakuten. It is possible that alternate models will arise. Maybe there will become a different model, maybe something like the Wi-Fi Alliance that guarantees interoperability between all the software components that claim they're Open RAN. But for now, definitely it's going to be up to the operator. The fourth impact will be the MNOs have to take full responsibility to manage this hugely complex and diverse environment. So moving on to the next impact, what skills will be required in this new complex software environment? Well, already it's pretty useful for any telecom pro to have TCP/IP networking training, a CCNA, a Cisco certification, or something comparable to that, so that you can understand layer 2, 3 in the stack, maybe higher up in the stack for some of the applications. But having that understanding about routing and signaling in layer 2 and 3, very essential to a telecom career. In the tool chain stack, those open source applications, OpenStack, Akrino, Linux, Apache, Kubernetes, it's also going to be helpful to understand those, if only to help the business operate better. You may not have your hands on the keyboard, but someone has to tell the business, someone has to do the mapping between hands on the keyboard and business impacts. The managers will need to have that type of understanding of that open source tool chain so that the business can take full advantage of. Next is the software development and programming environment, what's commonly called DevOps, how to manage a software lifecycle. Somebody needs to do that. And with all that different software, with all those different changes and upgrades going on, there's going to be release management, there's going to be rollbacks and roll forwards, hugely complex environment. Somebody needs to understand that for the operator. So DevOps training is going to be really essential. This is something we never need to have before. Vendor and project management. Now, these are pretty established. I don't know if there's any training for vendor management, but project management, there's like a PMP type of certification to help you understand what are the important tactics and capabilities in managing complex projects. Managing vendors will be a component of that. So this type of certification will be important to your career. And above all, the ability to learn and acquire new skills is more important than it has ever been. Telecoms is changing faster. In fact, in the future, we may not even call it telecoms anymore. It's just, a lot of what we're doing with Open RAN and with 5G is just you kind of back porting in IT best practices from the last 10 to 15 years. We're playing catch up, but we're going fast. That makes it very exciting. So here's the fifth impact. Telecom pros will have to acquire new skills. So my name is Russell Lundberg, and I've been working in telecoms. I've been working in mobile technology for operators around the world during the last 30 plus years, almost 32 years now. And this is the most exciting time with Open RAN and 5G. The changes that are coming our way are absolutely tremendous. For you, try to get the skills you need to go forward. Those on the last slide I just showed for DevOps and project and vendor management and the open source software and Cisco type of certification in networking. These are going to help your careers tremendously, and I'll look forward to talking with you about it. Again, go to pages.cafetele.com/TWA to download a PDF of clickable links of the key players collaborating on Open RAN. And if you want to talk, send me an email after that, and we'll get together and talk about Open RAN. Thank you so much for listening. It's been great talking to you.
Cheers, Russell. Thanks very much for a great presentation. If you did not manage to catch all of the presentation, please note that it will be available on demand for the remainder of Telecoms World Asia. Stay tuned for more presentations in today's theatre. Thanks.